Okay, let's continue on question 6. Okay, we've just finished 2 questions using graph to find the equations. Now we are going to do the other way around. We're going to use the equation which is given and find the y-intercept and asymptote, and you need to sketch the graph. Okay. So that means there are a few things for us to find out before we sketch the graph. First, let's find the y-intercept. Okay, y-intercept, you just put x equals 0, then you have y equals 2 to the power 0. Okay, some people will make a mistake here. They would just think, oh, this would be 0 plus 4. Is that true? Is that correct? Think. 3 seconds. 1, 2, 3. Okay, so I guess most of you know the answer. 2 to the power 0 is 1. It's not 0. Because some of you, when you learned index law first, when you first learn index law, some of you will read that's 2 to the power 0 like 2 times 0. So that's why you have an impression, wrong impression, that 2 to the power 0 is 0. Actually, it's 1. Okay, so this is 5. So y-intercept is 5. So where is it? Okay, let me mark it on the graph. So this is our y-intercept. Okay, how about asymptote? So we understand all the asymptote in exponential graph must be horizontal, right? So let's say it's horizontal asymptote. So horizontal asymptote, of course, is a horizontal line. For all horizontal line, the equation must start with y equals a number. So what number it should be? Okay. So in the previous video, we've shown that when you have that plus 4, okay, that means you raise the basic exponential graph from the x-axis upwards by 4 units. So now the horizontal asymptote should be plus 4, right? So you just write y equals 4, which is horizontal asymptote. Remember, in the examination, if you just write horizontal asymptote is 4, then I can't give you mark. Okay, let me say it again. If you just write horizontal asymptote is 4, then you got no mark. You have to write y equals 4, okay, because this is an equation, okay. Right, so let's try to locate where's a horizontal asymptote. So it should be y equals 4. Okay, I need to draw a horizontal line in that case. Okay, so this is the line I'm going to draw. Okay, so let me make it easier to look. Okay, so this is our horizontal asymptote, y equals 4. Okay, how can we sketch the graph? So you know that's 2, which is greater than 1, right? So we understand this. Okay, so this is graph. If you have y equals a to the power x plus something, right? If a is greater than 1, then the curve is always rising. It must be an increasing graph. It's a growth graph, right? So in that case, since 2 is greater than 1, so obviously it should be rising. Okay, so how can we draw the graph? Okay, in my case, it's a bit difficult for me to draw. All right, so because I'm using electronic pen, so it's a bit difficult. So I might need to get a few extra points to help me if I want to draw it accurately. But in the exam, I'm not going to have such time. Okay, so I'm just going to draw it really roughly. All right. This time's not too bad. Okay. Just going up like this. Okay. So that's how we do it. Okay. So let's have another question. Sketch the graph for this one. So this time you see this A is less than 1 but greater than 0. So you will expect to see a completely opposite graph. So this time you see a declining graph like this. Okay. But anyway, let's find the y-intercept first. Put x equals 0. Again, y equals 1 to the 1/3 to the power 0. So again, remember that's 1 minus 1, which is 0. Okay. And where is the asymptote? Okay. So you see that's number 1 here, but don't forget to include the sign in front of the 1. So that's actually -1. Okay, so our asymptote is, can we just write -1? No, which is wrong. You have to write y equals -1. Okay, so I might just use the line I used before. Okay, so I'm going to draw the asymptote first, this case. So this is our asymptote. And okay, the asymptote is y equals -1. And our y-intercept is x equals 0, y equals 0. So here is the y-intercept. So you need to pass through this point and your approach is y equals -1. Okay, from which side? Because now the base of the exponential function is 1/3, which is less than 1. So understand this should be a declining graph. Okay, it should be declining all from left to right. Okay, so we will expect to see something like this. Okay. Oh, it's really difficult to draw it properly, but anyway. Okay, so this side might just draw it like this. Okay, of course, if you want to draw it properly, then you need to get more points, but in the exam, it's not really necessary. You know, once you've got the shape correct, you got the asymptote, y-intercept, I will give you full mark. So don't waste your time to find extra points. Okay, so next question. So remember, we are still in paper 1, so you can't use calculator, right? So next question is about COVID, new cases, all right? And so for those modeling questions, it's really important for you to get the definition for those dependent and independent variable. Okay, in this case, obviously this n is our dependent variable and this t is our independent variable. You see another a there, which should be just a parameter. Okay, so what's the n here? So this is a number of daily new cases of COVID-19. What's t? All right, so t is the number of days. All right, so this is very important. The unit days after an outbreak. So it starts from outbreak. Okay, right. And they will give you some initial conditions according to the official records. There were 10 cases at the start of the outbreak. So what do you mean by at the start of the outbreak? That means at t equals 0. Okay, 10 cases. 10 is number of cases. So this should be n equals 10, right? So we will use this kind of modeling equation and also the initial conditions to solve the problems. Okay, so part A, determine the value for A. Where's A? So A is right here, if you can see it. So A is there, right? How could we find A? Of course, we need to use the initial conditions. T equals 0, N equals 10, and you put those values into the model, right? Okay, so remember that's t to the power 2 to the power t over 3. So that's 0 over 3. Okay, so of course 0 over 3 is just 2 to the power 0, right? 2 to the power 0 there. And which would just be 1. So you got A equals 10. That's it. Okay, so and then you need to find the determined number of cases after 12 days. Okay. That means you need to find n when t equals 12. Okay. So again, so we need to rewrite the whole equation, which is 10 to the power 2 to the power 10 times 2 to the power t over 3. Okay, so in that case, if we put t equals 12, what we will get? Get n equals 10 to the power 10 times 2 to the power 12 over 3, 2 to the power 4, and you know 2 to the power 4, it must be 16. All right. Here, be careful. You should not use 10 times 2. You have to do 2 to the power 4 first, because the power always get priority over multiplication, right? So that becomes 116 cases. You can say that this is just 160 cases. Okay, right. So the next question is a little bit difficult. It's a complex familiar one. Determine the number of days it takes for the number of daily new cases to be doubled. Number of days. Okay, to be doubled. All right. So what does it mean? So we know at the beginning it should be only 10 cases. So when the number of cases double, it should be 20, right? So let's say n equals 10 at t equals 0. Okay. But now you're going to double it. So it's 20 at t equals. Okay, so we don't know the time, so you need to solve for t. Okay. Okay, just I need to pause a moment. Okay, let's continue. Okay, so you need to find t, right? How can we do it? Let's try to rewrite the equation, rewrite that modeling equation again. So we have n equals 10 times 2 to the power t over 3, right? So let's say now our n is 20. Okay. And of course, the next thing you need to do is, can we multiply 10 into that 2? So some people might do this one because they see 10 times 2. Is that okay? Okay, 3 seconds. Something wrong here. 1, 2, 3. Okay, it's wrong. Why? Because you can't multiply 10 to 2. 2 must locked by the power. Okay, so the power of t over 3, that's power have priority over 10. So 10 cannot be multiplied to 2 in this setting. So the only thing you could do is to move that 10 to the left hand side. So you're going to divide 20 by 10, and you keep that 2 to the power on the right hand side. So it becomes 2 equals. Okay, so how can we solve this? Again, you see a common base. So that's 2 means 2 to the power 1, right? So you have 1 equals T over 3. So that means T3, 3 watts. Remember, the units are always days. So that 3 days. Okay? So it takes 3 days for the number of cases to be double, right? And how about the next question? Determine the number of days it takes for the number of daily new case to be increased from 400 to 1,600. How long it takes? Okay, so for 400 to 1,061, to 1,600, how many times it has increased? So you see that should be 4 times. 4 times 401 equals 1,600. But what's the relationship of that's 4 times to the answer we've just got for the time for it to be doubled? Okay, so we're understanding the exponential graph. You will always take the same time for the number of cases to double. Okay, so we understand from 10 to 20. So from 10 to 20, it takes how many days? It takes 20 days. 3 days, sorry. I got it wrong. So how about from 400, let's say when it's double to 800, how many days? 3 days again. So they are the same, okay? So that's the one very important aspect of exponential growth. It takes the same time for the same number of for the same factor you multiply to the previous number of cases. If it takes 3 days for you to double from 10 to 20, then it would take the same time for it to be double from 400 to 800, right? So it takes 3 days for the number of cases to be increased from 400 to 800. But how about from 800 to 1,600? Again, it's another 3 days. Okay, so totally it takes 6 days, okay, for the number of daily new cases to be increased from 400 to 1,600, right? Okay. Okay, the next one is a bit of conversion between logarithm and exponential function. So I will show you a little bit about the definition of logarithm and exponential form. Okay, so we see that a to the power x equals y is equivalent to logarithm a logarithm to the base a of y equals x. So you see, these are the relationship. Logarithm, you will get the index. Okay. All right. So that's the relationship between the exponential form and the logarithm form. Okay. So I would just possibly this one is quite useful. Let me just copy it. Okay. So let me just put it to our solutions so you can have a comparison. Okay, so I'm going to use this one. Try to get our equations into the logarithm form. Right now it's exponential form. Okay, so I might just get a copy. Okay, right now this is in the exponential form. Okay, can we get it into logarithm form? Right, so let's see. First, I need to remove that's 10 to this side. Why? Because I try to get a power function on one side, the rest of the thing on the other, right? So I will get n equals n over 10 equal 2 to the power t over 3. Okay, then from this, I'm going to use the logarithm. Okay, so what base shall I use? Okay, so remember, if the base is a, so that will be the base for the logarithm. So obviously the base is 2 in our case. So let's write logarithm logarithm 2 here. And all right, so what should be the y inside the logarithm one? So it should be, okay, the result of that exponential function, which in this case, which is n over 10. So just put n over 10 into the logarithm, and that one should be equals to the index. The index is not just t over 3. Okay, are we done now? No, because in the questions I express t in terms of logarithm. So you must only see t on one side. So I still need to move that 3 to the other side. Okay, how could we do that? I'm going to multiply that 3 to the logarithm. All right. All right. So if you like, you can rewrite the whole expression as t equals logarithm. Okay, so that should be the answer now. Okay, so I'm going to take a break. When I'm coming back, I'm going to do the rest of this revision exercise. Okay, see you later.